So friends, in this video, I will be talking about angle of dip. But before that, it is important to understand how the magnetic lines of force are shown for the Earth's magnetic field. So you can see here, we have got this Earth's magnetic field here. This is the North Pole, this is the South Pole, geographic North and geographic South Poles. And this is how the lines originate and then they again merge into the Earth. They create a complete circle, okay? Now, what is a angle of dip is that the angle created by the bar magnet. So you can see here, angle created by the bar magnet with the horizontal surface. So right now in this case, when the plane is at near equator, the angle between the horizontal and angle between the bar magnet is zero because they are parallel to each other. But if we talk about the northern hemisphere, so if you consider this particular picture, so here you can see that magnetic lines are curved, right? They are not horizontal to the surface. Or here the magnetic lines of force were parallel to the horizontal surface. But over here you can see that lines are curved like that, magnetic lines of force. And that's why what happens is that this particular bar magnet makes an angle with the horizontal. You can see here this angle. This is the theta angle, okay? And this is the surface. So this theta angle that is created by the bar magnet with the surface is called as angle of dip. And this angle of dip is positive in the northern hemisphere. But if you talk about the southern hemisphere in this example, that particular magnet is creating again the angle with the horizontal, but it is considered as a negative angle of dip. So if you are told that angle of dip is positive, then you can say that the plane is flying in the northern hemisphere. If you are told that angle of dip is negative, then you can say that plane is flying in the southern hemisphere. And how you can remember this positive negative thing is using this syntax. So you have to start from the horizontal and then reach to the bar magnet. So here we are going in this particular direction, anti-clockwise direction, and that's why it is considered as a negative angle. And that angle is always within this range, minus 90, 0, 90. So if you talk about the northern hemisphere, that angle is always between 0 to 90 degrees. And if you talk about the southern hemisphere, it is from 0 to minus 90. That angle is minus 90 over here in the right, over here in the south pole, and plus 90 degrees over here. Because here what is happening is this is the surface, horizontal surface, and this magnetic lines of force are making 90-degree angle, okay, over here. Other important thing that you need to remember about the angle of dip is that with the angle of dip, you can calculate horizontal and vertical components of the magnetic field. So if you are giving the magnetic field intensity at a specific point, you can split that into horizontal and vertical component, okay, BH and BV, and that is possible with the help of angle of dip. So if you consider, for example, this one is the horizontal surface, and let's say this is the theta angle, angle of dip. If you know the total intensity, the field, magnetic field intensity, say B, then if you want to calculate the horizontal component, say BH, that will be B cos theta. Okay. And if you want to calculate the vertical component, that is BV, that will be B sine theta. Okay, so this is also very important thing to remember. If you are given the angle of dip, then you can calculate horizontal and vertical components of the given magnetic field. Thank you for watching.